All right, good afternoon, everybody. So today we're kind of expand on our games that we've done so far, right? So far there's just sort of been a single screen and everything we just kind of throw inside of that main.py file. So what we're going to look at today is adding in multiple levels into a game. And we'll do that using Singleton objects. This is a design pattern that's used in software engineering to kind of simplify how things work. And we'll take a look at how those two are related here as we're going through. Then we'll talk about the update draw loop, which is a pretty standard construct in game design where we perform some kind of update on the state of the game, draw the state of the game, then loop back and do the update, draw the draw, update, draw, update, draw. And we keep repeating that over and over and over again. Okay? Some announcements. There won't be lecture on Wednesday. I'll be down here and I'll help you with any of your homework assignments that you have, but there won't be like a speaking lecture like this because I want you all to have a chance to go to the career fair up in the Fargo Dome. I think you should definitely go and just from your sophomore into your senior year, it's a great time to make contacts with people out in industry so you can get a good internship, good job. And I just wanted to make sure that you had time to go do that. So you can still come here and we can work on the homework assignment that I'm going to be assigning, but I just wanted to give that opportunity for you. The new assignment should be up and we'll talk about it towards the end of class here too. Hopefully you downloaded this multi-level template. It's actually a skeleton that we'll have a walkthrough during class today. Okay, but before I kind of get into that walkthrough, I wanted to talk a little bit about a review from last time. So here's a question for you. Let's see if you guys can get this. All right, we'll take a look and see what you guys got here. Most of you got it. So the main idea is just don't repeat yourself, right? We went through that in-class exercise last time, which helped us take that class and hopefully not repeat ourselves when we're building the code like this. Okay. Again, I just wanted to practice this retrieval learning so that you can keep up with the material here. All right, so today I wanted to start out with a look at some of the basic Python coding standards so that you can get a sense for how Python uses its names and how it's different from what you might have learned in Java, for example, in 160. So we'll look at that kind of as the beginning, and as we're going through the skeleton that I've got for you, we'll look at that as well. I'm going to go and talk about the singleton pattern for a little bit, what it does, how you implement it in both Java and in Python. We'll talk about that update draw loop. Like I said, you have an update that occurs, so you perform some kind of logic update inside of your game. You draw the state of that update, go back and repeat. Okay. And we'll be able to, after we've gotten this kind of background, we'll be able to create a level-based game. So rather than just having one screen with cats and suns and houses and stuff on it, right, we'll be able to build a more complicated game and be able to split up the project into separate files so it's much easier for you to work in teams. Right? The idea is that you'll be able to have one person work on one screen or one part of the game, another person working on another part of the game on another screen, and you'll be able to merge them back together by using this skeleton that's here. Okay. So first, like I said, talking a little bit about Python conventions first. This is a link to the PEP protocol for Python. It's a list of particular conventions that are used. We've talked about some of these already, but things like class names should be given as camel case with the first letter capitalized. Right, so some examples that we'll use today include a level manager and a title screen. Right, so these are different things that we'll actually put, or we'll have inside of the skeleton that we have. Okay, method names and variable names should all be lowercase with underscores between each of the words. Constants, all uppercase with underscores between the words. And remember that Python doesn't have specific constants, right? You're not telling it it's constant. This is just a way to tell Python, hey, or future programmers, that this is a constant. Okay? Another thing like that is you put an initial underscore character on any instance variable that you're trying to say is private. Right? Python doesn't have access modifiers like Java does, right? You don't have public, you don't have private, you don't have protected, you don't have things like that. But you can notify future programmers, hey, this is meant to be a private variable, don't modify this directly, by adding this underscore character in front of it. So it's just sort of notifying the future maintainers of a private variable. Okay? And like I said, I'll try and guide you through and show you some of those conventions as we're going through the demos today. Okay, so this is meant to be a follow-along. So if you download the template file from course content, you should be able to find it on Blackboard. And we'll kind of take a look at the files that are there and modify them a little bit. I'll kind of do that here too so that you get some time to follow along. We go to course content, go way down to the bottom, there's this multi-level template. Go ahead and open that. Show in folder. Make sure that you extract this rather than double-clicking. I've seen some people double-click into here. And there's multiple files, so we need to be able to access each of them. So right-click on that and go to extract all. And this will actually be the base for your next assignment too, so it'll be a good thing to kind of follow along. And we're actually going to look at level manager first. Okay? So this idea of having multiple levels or multiple screens in our game is going to be the focus of most of today. So I'll open that up here. Make sure you use 3.5 because that's what's installed here, where Pygame is installed. We'll come back. Before looking at the code specifically, I wanted to talk a little bit about what this code is doing conceptually before looking at the actual implementation of the code. So I want you to think about each of these game levels as stackable objects. So something that you can put inside of a typical computer science stack. Right? Right now, we only have one level. So adding more could be a matter of putting something into a stack. Okay? And you can imagine that whatever happens to be at the top of the stack is the thing that's being displayed right now. Okay? And you can, the nice thing about that is you can remove something from the stack, and whatever was behind it, right, you're able to display that information again. Okay? A sec. Right, so you push things onto the stack, like a title screen. Right? Let's say we have the Super Mario Brothers 3 title screen. Right? A little Mario running on the bottom, press start to begin, whatever you want. Right? We would have that screen show up first. To do that, right, we would just have to put it into the stack. And since it's the top of the stack, it's the one that's being displayed right now. Okay, so if you ever wanted to go onto a different screen or have something else show up, if you wanted to go into a different level, all you would have to do is push that next level onto the screen. Okay? And you just do that by calling methods on that stack. So, right, you press start, you go ahead and go, and the idea is you go in and start the game. This pushes the game screen onto the stack, like we've got here. And again, whatever's on the top of the stack are the methods that you'll call, right, in order to actually display and interact with that particular screen. Okay. Right, so in this particular graphic, game screen is up at the top of the stack, and that's the one that we're going to be interacting with. Now, another nice thing that this particular interface does is that if you happen to pop everything off the stack, right? If we remove the game screen, then remove the title screen, the stack is empty, which in this case means that the game is done, right? We can actually be all the way done, right? We can quit the program, we don't have to worry about it anymore. Right? It keeps track of when you want to be able to quit the game. Okay, so the thing that's handling this stack is, I call it level manager. And what it is it's actually a singleton. And we'll kind of look at each of these terms, right, what singleton is, and then look at the actual code of the level manager as we're going through. The bottom note here is that for the more advanced students in the room, you might think, wait a second, this would probably be better as a state machine, right? So I'm at a particular level, some series of actions occurs, and then I'm in a different state, right? Then some series of actions occurs, I can transition to a different state. And then I could transition to wherever I wanted to go, right? I could go all the way back to the beginning if I wanted. I could go all the way over here, go down here, right? Like a state machine. And that's probably true. But I wanted to have something a little bit simpler to kind of build upon, right? So we'll look at state machines if there's time later. But we'll look at this stackable idea first. And it's what'll be used in your assignment. Okay, so first, what's a singleton? The idea is that you have a class that has either 0 or 1 objects associated with it. Right? Typically you have a class, you can make a whole bunch of them, right? If I have an animal class, I can make all sorts of animals, right? In this particular case, I only want 1 level manager, right? If I suddenly have 2 level managers, there's a problem. I'm like, which one should I pay attention to? Right? So having this software construct of having a singleton allows us to make sure that there's only one thing that we're actually adding and removing those screens, those levels from. Okay, so in UML, right, you would see this as whatever the name of your class is. You have a private, right, it's the minus sign there, instance variable that refers to the object, right, the class there. Okay, so this would be the one instance of this class. Okay, then there is a private constructor, right? So the only place that you can actually create objects of that type is inside of the singleton class, right? You can't do it somewhere else, right? You have to do it inside of that class. And so the only place we can perform some kind of access, right, the thing that's not encapsulated inside the class is this getInstance method, right? So that we can actually get that particular instance variable that we've prepared, right? And again, so that there's only either 0 or 1, depending on the implementation. So here, right, some Java code for the singleton, right, would be, here's our instance. It's private, right? Static meaning there's only the one. Final meaning we can't change it, right? And we create it immediately, right? So we just create that one singleton object right away. Okay, private meaning we can't construct this anywhere else. This is the only place where we're ending up constructing. It's actually a pretty short file, right? And then this last getInstance, right, we're just returning that particular object. Right? There's no way to make any more objects, there's just the one object. Okay. Now how do we do this in Python? It looks a little bit different. Partly because, right, we don't have access modifiers in Python, so we have to go around it a little bit using some different things. Okay, so this is actually what's inside of if you would open up Level Manager, this is what's inside of there right now. So you can kind of see, first of all, things that are the same. Right? So first, class Level Manager, we know what this is, right? We can create a class. It's derives from object. Right? But this is kind of new, right? So we have this inner class, right, which has 2 underscores next to it. Okay. This, by having this class inside of this one, it's actually not possible without some contortions to actually get at this class. This is the closest thing we can get to kind of building in pure encapsulation inside of Python. We can put this inside of here, so we have to do some extra stuff in order to get at that class. Okay? And like it says, right, inner class, this is where the implementation goes. So this would be where we would create our level stack, right? The conceptual model that I talked about earlier, where we're pushing on screens, popping off screens, right? That's where we'll put that. There's still an instance variable, and right, this is on this indentation level, so we have an instance there that we can get. Okay, now actually creating the instance, the way that we change it is inside of the constructor here. Okay, so we've got a constructor. If we call level manager, right, to create a level manager object, rather than creating a brand new object, what it does is it checks to see if that instance variables have been set to something. Right? If it hasn't yet, we can create one. But we're not creating the class, we're creating an object of the inner class. Right? This is, we're creating level manager dot underscore level manager. That's the internal, right? The inner class there. Okay? So that means that we'll have just one instance. Right? If we try and call this, if we try to construct another one, right? We try to call level manager again. Right? If not level manager.instance, that'll be false. Right? We'll skip it. It'll only ever create this once. Okay? This second bit, right, this function here, getAttr, what it's doing is it's getting attributes and pushing it into the instance. So normally if you would call, there'll be a getCurrentLevel, right, that will have to peek at the top of the stack. Right? Normally if you would call level manager.getCurrentLevel, it's going to be looking for a def somewhere in here, right, at the first level. Right? But we want it to look inside of that inner class, right, that's hidden away, and hidden away on purpose. Okay? And so that's what this does here. Right? It actually goes into that middle class. Okay. Questions about this so far? I'll actually start typing here in a second. Okay. So, you kind of see that it says you need to implement your manager right inside of here. And so what we need to do is we need to create an instance variable, first of all, for our stack, right? So I'll go ahead and do that. Easy enough. We go self dot underscore level stack equals left and right braces, right? That'll creates a list for us, right? And that's really all a stack is. It's just a list with appropriate operations on it. Okay, and I put it inside of the constructor, inside of this inner class here. Okay, so next we just have to be able to interact with that. Right, so if we have a def load level, self level, what would it mean to load a level? That means to put it on the stack. So it's the next one to be viewed. Okay, push onto a stack. We just go self dot underscore because it's a private variable, level stack dot append. Right, so we're just, right, we've got the self argument, which indicates that it's a method, a class method. Level is what's coming in, right? Because we want to be able to put a level onto the stack. And we just append it onto the end of the list. Okay, say we want to leave a level. How do we do that? Def leave level. Won't take any arguments, right? We're just popping something off the stack. And again, Python is nice enough, in this case, to name it what you're expecting. Just call it pop. Okay, so we got this list. We're putting something onto the end of it. Pop takes it off the end of it. Okay, so to peek, right, to look at that very last, in this case, element that's in the stack, we need to be able to access the final element in the list. Right. So we'll do that with a getCurrentLevel. Def getCurrentLevel. Again, just self, because that's the, again, this is a class method. And one nice thing about Python is we can get that last element really easily, right? So self dot underscore level stack, like that, and I want to return it. Okay, so this is probably some new syntax for you, right? But -1 on a list just means the very last item on the list, right? We don't necessarily, we can, but you don't have to do the stuff you would have to do in Java where, like, right, when self dot level stack minus 1. Right? There's a nice little shortcut, right, that tells us where the very last item is. Okay, the problem is we're not quite done yet. If there happens to be nothing on the stack, right, if there are 0 elements on it, this will crash. Right? We can't get the last element if nothing's there. Right? So we'll need to add an if statement in order to check for that. And again, the most Pythonic way to do it is something like this. If not underscore self dot underscore level stack, we can return none, else return that. Okay, so the idea here is that Python has this idea of falsy values. This is not actually a true or false value, right? Self dot underscore level underscore stack, that's just a stack, right? But if it happens to be empty, right, the empty list, this will act as if it's false, right? So if it's empty, this is false, not false is true, it'll return none, okay? And so this is the more Pythonic way of writing an if statement like this. I mean, you could do it the other ways, right? If you could check to see the link, if the link to the list equals 0, right? This is valid syntax. This is just the more Pythonic way of doing it. Okay. If you haven't been following along or want to double check, I've got the methods up here too in the slides. Okay. So you may have noticed, right, we've got this level manager that we've now created, right? But we're actually kind of more interested in how the game works, right? We want to see what kind of things we can put inside of there. All right, so we're actually going to look at main.py now and see what's wrong with it. So I've actually purposely left some things out to help you learn about errors that you might see and ways to use importing. Okay? So let's go back here, we'll open up main. So this will actually, okay, so this actually look a little bit familiar, right? Some of this looks like the base template stuff that you were including with your one-screen games, right? So things like the screen, right, where you're saying how big it is, right? Or the clock, that's from the old stuff, or init, that's from the old template code. Right? New stuff, right, is like this here. So level manager equals level manager. That's actually creating that singleton object for us, right? And we're loading on the title screen, right, before we actually get inside of the actual main program. Which makes sense, right? We want to be able to play the title first. It's a good place to put it. Okay, now the actual program loop, at least right now, looks pretty empty. It's okay, it won't ever have a ton of stuff in it. Okay, up at the top, every single time we go through a frame, we check and see what level we're on. Okay, that's just what that first, right after the while loop there, what that line does. This here is checking to see, remember how I said if the stack was empty, that it would immediately leave the game? That's what this is here. But if there's nothing on, if there isn't a current level right now, we can break out of the loop when we'll be done playing. Okay, right now it doesn't have any game logic, right? We're missing update and draw, so it's just filling in a white screen right now. Okay, and this stuff is from all of this is from the template, right? So we have the thing that we're drawing, we have the actual thing on the screen, we flip them, we make sure that it keeps up at 60 frames a second, or limit it to it if it's going faster than that, and then the keyboard and event stuff is down here. Okay. And I think down the bottom is just a quick. Okay. So you can try and run this, right? If I go run module. Uh-oh. Red text already. Right, so name constants is not defined. Now before I kind of fix that for you, I just want to see how well you guys did on reading the book. So here's a question for you. for whatever reason, takes a while for it to kick in. Let me see how you guys are doing. It's like we're kind of more over the place than something. Okay, looks like you're kind of all over the place. So let me, first of all, show you the state of what's going on here. All right, so we have this, over here we've got our main, which we're importing this library called myfunctions, which just has foo inside of it. Right? And we have this method called foo, right, that we're calling. Okay, so if we run this, right, there's the name foo is not defined error. The problem, right, is that this method, right, the foo method, is not in the local namespace, right? It's inside of the library's namespace. So in order to access the library's namespace, we actually have to put the name of the library first, dot whatever it is. Right, so here, we could also pull it from the, into the local namespace, but first we'll look at this. I spelled that right. Alright, so now if we run this, save it. Now it knows where it is, right? It's inside that library's namespace. So we have to append that, the name of the library, then the name of the method, or the name of the class, right? Whatever happens to be inside of that library file that we want to access. Okay. Now, with respect to the main file that we had, right, our game that we're creating here, there it is. You'll notice a couple of places where it says constants.white, right? Or up here, constants.screenWidth, or constants.screenHeight. Right? That would mean to me that I have to go, that I just forgot to import my library. Right? So import constants, right, which will load in that constants file. And if we actually look inside of that, well, look what constants is. It's actually not that complicated. It's just a couple of things I want to be able to access everywhere, especially something like screen width and screen height, so that I can, find the borders when I'm inside of a screen, or if I want to just have red only in one place, right? Don't repeat yourself. That way you don't have to redefine red everywhere, right? Or white everywhere, right? You can just call constants.white. It's in that one place. Okay, so now we can try and run this again. So, sort of the same problem, except now it says level manager is not defined. Right? And before I kind of talk about that error, I've got another question for you. Well, that just kind of says what we had to do to fix it. Here's as usual, not going to wait for everybody, so we'll hit the button here. Alright, looks like more of you guys in some of the other sections. Yep, the majority answer here is right. So let's look at a couple of the other ones first. So import local would mean that there's a library file called local that you're trying to import, right? That's not right. This B is also, make sure there's a draw here. B is not proper syntax. that we wouldn't be able to do that. Okay, this one's close, except what's going to happen here is it's going to look for a method called local inside of math. Right, so it's going to try and find either a method or a class called local and try to pull that into your local namespace. Okay, import math, right? In order to do that, right, if you would put this up at the top of a file, you'd have to be type math.pi or math.cosine or math.tangent, whatever you wanted to actually, whatever method you wanted to call inside the math library, you would need to prepend it by that library name. Now the question is asking you, what does it take to move something from the library's namespace and pull it into the local namespace? So you just go pi, you just put cosine, you just put tangent. Okay, and to do that, right, it's the from math import star. Okay, and at least with respect to the code that is here right now, right, let's go to main again. Right, let's say that I just did this, import level manager. Now that would be okay and all, except now every place where you see level manager like this, what we'll actually write is level underscore manager dot level manager, right? And personally, I just think it looks more clean if we don't have to append that library at the beginning. Also, we don't have to worry about name collisions or something like that. There is no other level manager object we need to worry about, which you would have to worry about if you had a library. If you had two separate libraries that had the same name function inside of it, you couldn't pull them both inside of the local namespace because one of them would override the other one. Okay. But in this case, it's all right. So if we go from level manager, import star, oh boy, wrong keys. Import star. You can also import just the class too. If you wanted to just import level manager, that'd be fine. And then if you're reading along here, right, we've got the level manager, but there's something else we're kind of loading the same way, the title screen here. So we'll want to make sure that we load that the same way too. So from title screen, import star. Assuming I've called everything right and spelled everything right. Oh, I didn't. Attribute load level. Oh, I forgot to save. Right, you can tell if you save something or not in idle, because it's got the star there up at the top. I forgot to save it after typing in all that stuff. So save, try it again. Go back to main. Again. There we go. Right, and remember I said that there wasn't any game update loop in here yet, so it's just a white screen. Okay, so our level manager is in there now. Right, now we have to actually use it somehow. Right, in order to use it, we have to look at this draw and update. Okay, when you need reminders later, there's the code to try and fix that. Does work, just has a white boring white screen. All right, so what's the idea here between this update, but how's the delineation of the jobs work here? Right, so we have a method, right, that will be called update, which can handle game logic, moving things around, detecting collisions, updating people's points, maybe providing some kind of power-up, things like that. That would all be inside of an update method. Right? A draw method, its only job is to draw things on the screen. Right, so the Pygame dot draw dot rec dot whatever, right, or all those different things. Or if you want to blit an image onto the screen, right, that would be drawing. Okay, and then there'll be a third thing. We're going to handle input separately. Okay, this is just taking in one of those Pygame events, right? So a keyboard press, for example, right, handling it inside of the screen here, and then returning back. Okay. Sometimes you'll see this combined with an update, but we're going to keep it separate just because the event is separate like that. Okay, and the reason I said you sometimes see this a different way is that I want to point out that this is not just a Pygame thing, not just this skeleton that I created for you kind of thing. This is actually a fairly common way of building a game. So you have this main program loop that goes through and performs this update and this draw method. Okay, and that's true in a couple different things. These are ones that I've used, but it occurs in all sorts of game engines. Right, so XNA is short for, XNA is not acronymed. It was a way for indie developers to create games on the Xbox 360. Right? You spent like $99 a year and you were able to publish your games and sell them in the Xbox Live Indie Game Studio thing. It has this draw and update loop, right? There's actually a load content method. There is an update and a draw that you override. You would repeat update and draw over and over again. When you're done with the game, it goes into an unload content, so you can destroy any content that would need to be resources free, things like that, right? And there was a draw and update loop in that. Unity, which is very popular 3D and 2D modeling game engine, also has this kind of functionality, right? So again, if you follow that link there, there's an update, which is code that's called immediately before a screen gets drawn. There's a fixed update, which is drawn immediately before a physics time step. So if you're checking for collisions and things like that, you'd want to put inside of a fixed update. But then there's all sorts of things that are done on a draw as well, right? So there's on call, there's drawing things. But like this execution order is way more complicated than just a draw and an update loop like it was in XNA, and more complicated than our update loop. Okay, just wanted to say, not just this, right? Trying to teach you a broader concept as well. Okay, so what is our screen, the thing that, the level that we're going to display on the screen look like? And we're going to create an abstract base class that'll help us to be able to perform these logical operations. Right, so we have this base class called screen. You could also call it level to try and disambiguate it from the Pygame screen. But whatever you want to do. Okay, this is actually inside of the list of files that I gave you. Right, and there's three separate things, right? Like I just said, there's something to handle a keyboard event. Right, we'll pass in an event as an argument. There's update, which just updates the logic of the game. And then draw with a screen passed in as an argument, right? So this is how you can do pygame.draw.rect with screen as that first argument, or if you're trying to screen.lit, right? That's that screen object. Okay. Now, to make something an abstract base class in Python, all we have to do is define the methods, right? So we have our three methods here with their class methods because we've got this self here at the beginning. And we just raise, or we, in essence, throw an exception. Right? So if we raise not implemented error on each of these methods, what happens is if you create a subclass of screen and you forget to implement one of these methods, right? You don't include an update method. What will happen? Well, it'll call that update method on your subclass. It won't exist, so it'll look in the parent where it'll find this exception. Right? So you'll get a runtime error showing that, hey, you need to implement this update before it'll work properly. Okay? All right, so now let's assume for a second that the game screen, title screen, all that stuff has been written. Right? That there's a way to draw things on the screen, there's a way to update things. How are we going to integrate that into the game that we have right now? And it really just takes calling the three methods at the appropriate places. Right? So we want to update, we want to draw, and we want to be able to handle a keyboard event. Right? So we can do that. Right, back in game now. Right, so rather than always displaying white here, we'll just go current level dot update and current level draw screen. Okay, and then whatever thing, right, happens to be at the top of the stack, we'll update it. Whatever thing happens to be at the top of the stack, we'll draw what's on that thing. Then if we want to actually get some keyboard information, right? We have to go down to our event loop, right? Because remember, inside the book it talks about how if you call this, it actually removes everything from the event handler, right? So you want to make sure that your call goes inside of this loop. And we'll go ahead and put it in there. So again, current level dot handle keyboard input, I think is what I called it. And we need to pass in the event. It's actually misnamed. All right, that's not this. Okay. Right, so now we have that draw and update loop inside there. Right, before I run this, I want to show you what kind of goes inside the title screen, what goes inside of that game screen. So if we open up title screen, so it's just a class. Whoops, I should have made it extend screen. I don't know why I didn't notice that either time. So we got the constructor, right, which just loads in a font there, and we can, and actually, because this text never changes, I'm just putting it inside the constructor, right? We can render it once and be done with it. Right, if you had to change this, you'd have to put the rendering inside of the update method, but it's one thing, never going to change. Plus, it allows me to show you what to do if you have an empty update method. Okay, so my title screen is just going to say Otto's game template in it. Okay. Here's our keyboard event handler. You can kind of see it looks just like if we were inside of that for loop. Right? If we're pressing down on a key, and that key happens to be an escape, we'll leave the level. Right? Leave level in this case, leave the title screen means that our stack will be empty. Right? So that the game will quit. Okay, here, if we press a P key, right, we'll actually push that game screen level on. Right? So we'll go into the game screen, and it'll be the thing that's at the top. Okay, now the update in the title screen doesn't do anything. All right, so we can call this pass method, which just says I'm done. Yeah. Okay, so that we're done with that method. It implements, it doesn't go down to its superclass, so it doesn't give any kind of error like that. Okay, and draw, relatively straightforward. Like it's the draw command that you've been putting inside of your main template. But now we're kind of separating it out so that we have different screens. And you can imagine, right, different people being able to work on these different screens. Okay, this one's just going to blend the text to a particular spot on the screen. Now if you want to see something where update is being used, we'll go into game screen here. E5. And this is just a refactoring of the bouncing rectangle from the book. But what I've got, right, is a series of instance variables, you have the underscore here, saying how big the rectangle is, where it is on the screen, and how fast it's moving. Okay. On the keyboard event, the only thing that we're going to do is, if we hit escape, right, we'll just pop that off the stack, meaning that the title screen is displayed. Right, so we get this being able to move almost like within an app, right? If you've ever hit the back button on an app, right, especially in Android, right, it'll go back to the screen you were on before. This kind of structure is used for that as well. Okay, so there's the keyboard event. Again, leave the level. And update and draw are just, we'll move the rectangle around. Right, those first two lines are moving the rectangle based on that speed. Okay, this sets here, just like the comment says, it just bounces things off, bounces the rectangle off the screen, whether that's the top, the right, the bottom, or the left. Okay. And then this is the actual draw method, right? So we have a white background, goes ahead and draws a rectangle, a black rectangle, and then a red rectangle in front of it. Okay. And you could call any kind of Pygame method you want inside of there to draw something, right? It doesn't have to be a draw rect like that. You could put an image there, anything that you wanted. Okay. So what does this look like now? We go into our game because I've already implemented those methods for you. Right, so there's the font being blended on the screen, right? This is the title screen. It's at the top of the stack. So now if I hit P, you should be able to do the same thing. And it'll switch over to the bouncing rectangle example. Right? You can imagine that not just a title screen, right, but you could have a credit screen, right, that has the name of the authors, maybe some copyright information, things like that. Maybe there's a instruction screen so that you can list how to play your game. You could have a settings screen that could handle changing the keyboard navigation or something like that. Right? But all these things could be separate screens that you can keep track of. Okay. Again, this is still just a stack, right? So if I hit escape, I'll go back to the title screen. Right? And if I hit P, I'll go back into the game. And you'll notice, well, wait a second, Otto, it's always starting up in that corner there. And that's just because of how I've written the game itself. So I actually create a new game screen object every single time I start the game. You could certainly create an instance variable and store the current game, if you will, inside of there instead. Okay? So that it would remember the old states of everything. Okay. So again, escape to quit the game. And then if you hit escape one more time, right, that would pull that title screen off of that stack, and it would quit the game. Right, let me just show you here. If you scroll down to the bottom, right, there hasn't been any kind of errors or things like that that have gone on. It's a smooth transition into actually exiting and moving between each of those stacks. Okay. Questions? Right, so like I said, the skeleton's going to be used for the next assignment. And the next assignment actually is I'm going to have you spawn off and create a brand new repository on GitHub. So if you open up, right, if you download the newest assignment, it should show up in Blackboard there. You can click on that, on the link that's included in there to create a new repository. So your new repository is something like assignment-6- whatever your team name is. All right. And then what you can do is, right, clone the repository, add all of the template files into it, commit, and push it into GitHub. And I didn't do that for you. I could have, right? I could have just put the skeleton files into that GitHub repository for you. But I wanted you to get a chance to practice doing that again, right? So I left it empty. After you've done that, you can kind of discuss within your teams what roles you want to take. Because like I said, it's kind of a bigger assignment. There's 3 different roles. I think one is art and sound engineer, one is a gameplay engineer, and the other one's like a file management engineer if you happen to be in a 3-person group. But go ahead and read through the instructions, figure out which one you want to do, and talk with one another too. All right. Otherwise, I'll ask questions one more time. Otherwise, I'll give you the rest of the time to kind of work and do group stuff.
Do you have preferences on what you want?